Hi, we are going to learn about Euler's method today. It looks like Euler's method, and some people do pronounce it that way here in the United States, but he was from Switzerland and he spoke German, and the way that you pronounce his name in his native tongue is Euler. Leonhard Euler is probably regarded as one of the greatest mathematicians, perhaps the greatest mathematician in all of history. He was definitely the most prolific mathematician of all time, so he advanced the fields of mathematics more than anyone else. He worked in almost every single area of math, and I would recommend you looking at a short biography of him on YouTube because he's a pretty interesting story. He went blind and continued to invent and expand the field of mathematics even after losing his sight. In fact, I think he produced more new advancements in mathematics after he went blind than before. The number E that we use in like Algebra 2 is Euler's number, and it's an E because of his name, and he was the one who discovered that value. So lots of interesting work that he has done in calculus and graph theory, really every branch of math. So today we're learning Euler's method, which is pretty much guaranteed to be on the BC calculus exam, at least one problem. And it's a method of approximating y values. Okay, so we're not coming up with exact values. We're using a process to approximate a y value of a function. So for our first problem, we are going to use Euler's method to approximate y of 1. So that's like if you were to do f of x, the x value is 1, we're trying to come up with the y. And we're given a differential equation. dy dx is equal to x plus 2, so that's a really super easy equation to use. We're also given a point, y of 0 equals 3. And we are not going to find this value by integrating. We're going to use Euler's method to approximate the value. We're going to find y of 1, and for this problem, we are going to use 2 equal steps. They're either going to have to tell you how many steps to use or what the step size is to do these problems. So the way that we set it up is we make a little table, and you're going to have to be the one creating this table. So you're going to have to remember what goes where. We're going to put x's here and y of x is here. Okay, and then, so this is like your point that you start with, 0, 3, 0 goes here, 3 goes here, okay? But then to the y value, we're going to add the dy dx such that we're on the point xy, and then we're going to multiply it times the delta x, which is the step size, and we do that to get us the new y value. Now, the way that I remember this heading is that y equals mx plus b, like your slope y-intercept form of a line. The new y value is going to equal the slope, this is the slope at the given point, times x, which for this we're using delta x, the change in x, the step size between the x's, plus the old y value, whatever we started with. They have to give you something to start with, okay? So for my first line here in my table, I'm going to add And now I'm going to go to my dy dx equation, and I'm subbing in the x and the y value here. But this one only uses x, so 0 is the x plus 2. So I'm just filling in the x from my point into this dy dx equation. That's my slope. Times, I need to know what the step size is, okay? So I'm going from an x value of 0, and I'm ending at an x value of 1, because they're telling us to find y of 1. And then we are going to use 2 equal sized steps. So that basically, if I start at 0 and I end at 1 and I'm using 2 steps of equal size, each one would have to be a half to get me from 0 to 1 with 2 steps. So my next x value will be a half, and then I'm going to end at 1. So the step size is 1/2. All right, so now I'm going to do some arithmetic. 2 times a half is 1, plus the 3 I already have equals 4. Whatever number I get here wraps around to start the next row. So then I'm going to go plus my slope, x plus 2, with this x and this y. So this time I'm going to go 1/2 is my x plus 2, and this is still times 1/2. The step size, they're equal steps, so they don't change. And then, so 2 plus a half, that's 5/2, times 1/2 is 5/4, plus 4. 4 plus 5/4 is 5 1/4. And that is the answer to the problem, because they wanted me to find the y value that goes with the x value of 1. So we've just used Euler's method to approximate what y of 1 is. Now, we're not going to do these next few steps on each problem, but just for the first one to kind of introduce the topic, we're going to say that was part A. And for part B, we are going to find the exact value of y of 1. So the way we would do that is by solving the differential equation, just like we learned how to do last time. So we're going to cross multiply 1 dy equals x plus 2 dx. And we're going to integrate both sides. So y will equal 1/2 x squared plus 2x plus c. And now I'm going to substitute in my point. I'm still using the same information I had here. Y of 0 equals 3. So y is 3 when x is 0. So that means c is equal to 3. So I have the equation y equals 1/2 x squared plus 2x plus, oops, I'm so sorry, 3. And I'm supposed to find the y value when x is 1, so I'll just sub in a 1 for my x's and solve for y. So 3, 4, 5 and a half, 5.5 is the actual y value if you do it the way we learned last time. So our approximation and our exact value aren't too far off. Okay, so part C says, how much error was in the approximation you got by using Euler's method? So the error is going to be equal to the approximation minus the exact value. So if they're equal, you have 0 error. And if the exact value is more, then your error is negative. And if your exact value is less, then your error is positive. So we're going to say the error is equal to our approximation, which was 5 1/4, minus our exact value, 5 1/2. So that's going to be an error of negative 1/4. So our answer that we got by the approximation was less than the actual by 1/4. And finding error is actually a huge area of mathematics. It's something that people look very closely at, because a lot of times approximations are available and we want to know how far off is this. Okay, so D, this is the last part. How could you get a more accurate approximation using Euler's method? So think on that for a moment. What could you do to still use Euler's method, but have a more accurate answer with less error in it? Well, I suppose instead of just doing 2 steps, you could do more steps, which means the step size would be smaller. Use a step size that's smaller. That would produce a smaller error. We took more little baby steps in between rather than big jumps. It's kind of like we're using the slope on a slope field to kind of predict the next value. We're just looking at where it points us based on where we're at and what the slope says we're going to and how far off we're jumping. So the more little tiny jumps that you do in re-evaluating what that slope is at that location, the more accurate your answer will become. Okay, next let's do number 2. Number 2 says f prime of x is equal to x plus y. F of 4 equals negative 1. Find f of 4.2 using 2 equal steps. So use Euler's method to approximate f of 4.2 using 2 equal steps. So this time they've switched us up to function notation, which is fine. We can do this using function notation. We're going to say x is the first heading, and then we'll go f of x, where we had y of x before, plus, before we had dy dx, so we'll go f prime of x such that we're on the point xy, and then we'll multiply that times delta x to get our new, we said new y value, so we'll say new f of x value here. So it really doesn't matter whether you use function notation or y values as the top of your heading, as long as whoever's grading it, me or the AP graders, can interpret what you are putting in each place. So you need headings that are decipherable by your reader, whoever's grading your work. So we're going to start with the point 4, negative 1. And we're going to add to that, I'm going to take this derivative equation, f prime of x, and we're going to add the x and the y. So x is 4 and y is negative 1. And then we're going to multiply that times the step size. Now I need to figure out what my step size is. I'm starting at 4 and I'm going to 4.2, and I'm using 2 equal steps. So that when it's decimals, I like to think of money. If I'm at $4 and I'm going to $4.20, and I'm going to go 2 jumps to get from there to there, it's going to be 4.1, then 4.2, so like adding a dime. So the step size is 0.10 or 0.1. I'm just thinking in terms of money, so I put 0.10. Okay, so now I need to do the arithmetic to figure out what my new f of x value is. So 4 plus -1 is 3. And 3 times 0.1 is 0.3. And -1 plus 0.3, it's like -1 plus 30 cents. It's -0.7. So that's going to be the value that rolls down to the next step. And my next x value is going to be if I add my step size of 0.10 onto my starting x value. So I'll go 4.1 and then 4.2 is where I'll stop. And y'all, it's not uncommon for them to use 2 step sizes. Technically, they could give you 2 steps. It's not uncommon for them to say to use 2 steps, but it could be more. It could be 3, I suppose. They don't usually have you go too far because they don't want you getting too heavy into the arithmetic and making errors there. They're testing you more on the method. So we're going to add to this the sum of the x and the y. So 4.1 plus -0.7, and that's going to get multiplied by our step size. 0.1 or 0.10 means the same thing. So 4.1 minus 0.7. Do you have to do this without a calculator? Yes, you do. They always put these on the no calculator portion. So think of it like money. If I have $4.10 and I take 70 cents away, that's like $3.40. And I'm going to add a -0.7 to that. Oh, no. I have to multiply by 0.1 first. Okay. So that's just going to scoot the decimal back once. So 4.1 minus 0.7 is 3.4. And then move the decimal back, that's 0.34. And then I've got 0.70 and 0.34. And I'm subtracting. So -0.36. And that's going to come back over here. Plus, oh, no, that's it. Just kidding. We're done. 4.2 is what we're trying to approximate for. So -0.36. All right. Moving right along. Number 3. We're given a dy dx of 2x minus y. F of 0 equals 1. We're going to use 2 steps of equal size to approximate f of -0.4. So I'm going to set up my headings, x, y, plus dy dx such that I'm on the point xy times delta x equals my new y value. All right, so I'm going to start with this point 0, 1, and I'm going to add to it whatever I get when I plug 0 and 1 in to my dy dx. So 2 times 0 minus 1, and I'm going to multiply it by delta x. What is my change in x? I'm starting at an x of 0, and I'm going to an x of -0.4, and I want to take 2 jumps to get me there. So that's going to be -0.2. your delta x can be negative if your desired x value is smaller than your starting x value. All right, so 0 minus 1 is negative 1. Negative 1 times negative 0.2 is positive 0.2. And if I add that to 1, I get 1.2. So my delta x is negative 0.2. So from 0, I go to negative 0.2, then to negative 0.4, which is where I'm headed. Starting at 0, going to negative 0.4 with 2 steps of equal size. And then my number 1.2 wraps down to the next step. And then I'm going to substitute this x and this y into my dy dx here. So I'm going to have 2 times negative 0.2 minus my y value 1.2. And I'm going to multiply by negative 0.2. Now I get to play arithmetic. 2 times negative 0.2 is negative 0.4. Negative 1.2 and negative 0.4 is negative 1.6. And that is going to get multiplied times negative 0.2. So negative times negative will be a positive. And when I multiply, I'm going to get 12, 2, 3, and the decimal goes 2 over, so 0.32. So I've got 1.2 plus 0.32, which is 1.52. Who would have thought calculus could be involving so much arithmetic? Thank you, Leonhard Euler. Okay, so we're going to pull this back over here, 1.52. Oh, and we're done. That's the answer. All right, here's our last one, and then I'll let you work on some practice of your own. dy dx is equal to 2y. Y of 0 equals 1/2. Find y of 1/2 using the delta x equal to 1/4. So I'm going to set up my little table. X, y, plus dy dx such that I'm on my point xy times delta x equals the new y value. All right, my starting point is 0, 1/2. My delta x is 1/4, so I'm going to go up 1/4 and I'm going to stop at 1/2. I'm going to add to this my slope equation 2y with this point 0, 1/2. So just 2 times 1/2. Multiply that by the delta x, which is 1/4. 2 times 1/2 is 1. 1 times 1/4 is 1/4. And 1/4 plus 1/2 is 3/4. Okay, so now I'm going to repeat. I'm going to go plus 2 times this time the y value for this line is 3/4. The delta x doesn't change. Okay, so 2 times 3/4 is 3/2. 3/2 times 1/4 is 3/8. And if I add 3/8 to 3/4, that's like adding 6/8. So that's going to give me 9/8. And that is the answer. All right, now you know all about how to use Euler's method. So have fun with that, and I will talk to you again soon. Let me know if you have any questions. Have a great day. Bye for now.